Welcome back to the deep dive. Today we are shining a light literally on a piece of hardware that's really at the core of high-speed internet.
Yeah, we are.
We're looking at the Thor broadcast F-PLC-1x2-LGX fiber optic coupler splitter. So our mission today is to figure out what this thing does and, why its features are so critical for your internet quality.
Right. And let's start with that PLC in the name.
Huh.
It stands for planar lightweight circuit, which is
Hmm.
really the core technology here.
Okay.
Think of it as a tiny optical chip. Its whole job is to take one incoming light signal and split it very precisely. This model is a 1-to-2 split, but the tech scales up massively.
So it can go way beyond just 1 to 2.
Oh, yeah. The sources show models that go all the way up to 2x64. I mean, that's huge for distributing a signal across a network.
And it seems pretty flexible, too. The docs mention they come in small casings, but also in, the standard 19-inch rack-mountable forms.
Exactly. So they can slot right into existing network setups. But let's talk about the specs, because signal strength is really everything.
Yeah, how do you keep the signal clean when you split it?
It all comes down to efficiency. The main metric is called insertion loss. For this specific model, that loss is only 4 dB.
And that's tiny, especially if that light has to travel for miles.
Okay.
So it's efficient, but is it tough? That signal has to survive some pretty harsh conditions to get to your house.
It absolutely has to. And that's where this thing shines. The source material highlights its excellent mechanical stability.
What does that mean in real terms?
It means it works perfectly from a freezing -40 Celsius all the way up to a blistering +85 Celsius.
Wow.
Yeah. So an engineer doesn't have to worry. They can install the exact same component in a cool basement or in a metal utility box sitting in the summer sun.
Okay, I also see some other advanced metrics here, like low polarization dependent loss. For those of us listening, why does something like that matter?
So that, along with a high polarization extinction ratio, basically guarantees signal purity.
Purity, even if things aren't perfect.
Exactly. Even if the fiber cable gets a little bent or stressed out in the field, these aren't just buzzwords. They're an assurance that your data gets through intact. When you see it's TLC certified, you should just hear guaranteed to work under pressure.
Got it. So to get that light signal into the box, you obviously need physical connectors. The sources list 4 types, and this seems to be where you get a trade-off between density and, I guess, speed of installation.
You nailed it. There's a really clear shift happening in the industry. You have the LC connector. It's tiny with a 1.25 millimeter ferrule, and it's perfect for high-density racks where space is tight.
But then you have the SC connector, which is a bit bigger.
Right, a 2.5 millimeter ferrule, but it uses a quick snap-in mechanism. It's often preferred for fast field deployments because the technician can patch it in much more quickly.
And I guess that's why the older types, like the ST with that bayonet twist lock and the screw-on FC connector, are starting to disappear.
They're on their way out. Speed and efficiency are just too important when you're building out a massive network.
So let's connect all this to the real world. Where do these super stable splitters actually live?
They're the backbone of, well, pretty much all modern connectivity. You see them in applications like fiber to the point or FTTX, and especially in passive optical networks.
Which includes GPON, right? The gigabit passive optical networks that deliver internet to entire neighborhoods.
Precisely. That's the main delivery method for most residential high-speed internet. They're also essential for local area networks, so LANs, and even for distributing high-quality cable TV signals.
And that's where that incredible temperature stability must really pay off.
It really does. Whether that signal is for a CATV system in a town that sees heavy snow, or it's powering a GPON network in a hot southern city, this one component is the unseen foundation keeping everything running.
So here's a final thought for you to take away. Just think about the engineering that has to go into one single component that can split a light signal up to 64 ways and do it reliably, whether it's in a deep freeze or the middle of a desert summer. That incredible stability, which we totally take for granted, is the silent hero guaranteeing your internet works year-round.